So, good afternoon, everyone, and welcome to the ITSP Bootcamp organized by the Aero Club. My name is Parth Lohia, and I'm a convener for this current tenure, and I'll be overlooking today's session. Over the course of this bootcamp, we'll explore the fundamentals of drone design, autonomous flight systems, flight controllers, mission planning softwares, and the complete workflow involved in building and operating modern drones. The goal of this bootcamp is not just to introduce theoretical concepts, but to provide practical knowledge as well that you can directly apply to your ITSP projects. By the end of these sessions, you should have a much cleaner understanding of how different drone systems come together and how to approach the design and development of an autonomous aerial vehicle. Today's session will focus on drone sizing, ECalc, and INAV. We'll also discuss how engineers choose drone components, how flight performance can be estimated before building a drone, and how modern flight controllers use GPS and navigation systems to enable autonomous flight. Feel free to ask any questions throughout the session. The more interactive the discussion, the more we'll gain from it. So let's get started. And just a small rule before starting, we will have to put you on mute throughout the whole meet. But if you do have any doubts, please feel free to raise your hands and we can unmute you. Or you can also put your questions in the chat section and we'll make sure to clear them. So without further ado, let's start with the first topic, that is drone sizing. I would now like to call over Subramanya to take over.
Um, yes, am I audible?
Yes, you are.
Yeah. Hello everyone. I'm Subramanya, second year student from MEMS department. I'm also a convener at Aeromodelling Club IIT Bombay. As Parth said, I'll be covering drone sizing and ECalc too. So let's get started. Let me share my screen. Um, Parth, can you see my screen?
Yeah, it's visible. Go ahead.
Yeah. So let's start, guys. So what do you think drone sizing is? You can s- start commenting, guys. Uh, So what do you think drone sizing is, guys? You can feel free to put a comment. Yes, I see a comment from Vishwajit, choosing motors and propeller size according to payloads. Yes, very good. Yes, Vishwajit, you are right. Selecting the right frame, motors, propellers, electronics like ESCs and all for also checking whether KV rating is suitable for large or small props and all to maintain a to properly for the required performance safely and efficiently. Also, it affects flight time, stability, and control, payload capacity, speed, and agility, as you can see in the slides. So, yes, here's the drone frame. You guys might have may encounter this term called wheelbase. It's basically the distance here, as I marked in this image. This distance between two motors which are placed diagonally, uh, 225 mm. This is called the wheelbase, and it determines maximum propeller size. As you know, there are according to the geometry, we calculate the adjacent side using this wheelbase, and then uh, we place it at we just diameter of the propeller plus the adjacent side plus the prop clearance should be less than the at this adjacent side. According to that, we get the maximum propeller size here. Yeah. So frame size. So 5-inch frame. Whenever you see something like 5-inch frame, 6-inch frame, it does not mean that frame itself is a 5 inches wide. It means that this frame is actually designed for propellers with 5 inches diameter. Yes. frame geometry is designed considering propeller diameter, propeller clearance, and motor spacing, as I said. So yes, pitch. What do you guys know about pitch, guys? You guys can keep commenting. Let's keep this session bit interactive so that I can understand like what you guys are thinking about these topics. Feel free to comment, guys. Uh, yeah, okay, nobody is commenting, so let me start then. Pitch is the distance moved by a screw in one rotation. Also, it determines how much air or water is moved when a propeller completes it one rotation. So as you can see, high pitch means it moves more air per rotation and best for speed and cruising. Here, cruising means, let me explain you cruising. Cruising means basically it's a steady state where a drone's altitude and speed becomes constant. Yeah, it's very simple. And high load actually it imposes heavy load on the motor, slower to spin up and less agile. Here, slower to spin up because as it moves more air per rotation, so it feels more resistance, the aerodynamic drag. So it's slower to spin up, and also in the low side, low pitch, you can see spins up instantly and highly responsive. And here's some data, pitch to diameter ratio, which you can see. If it's less than 0.7, it's for long range. If it's approximately 0.9, it's for freestyle. Greater than 1, it's for racing. So here's some data. I collected it from a research paper. As you can see, pitch angle. Pitch angle is basically the angle between the propeller blade and the angle of rotation of plane. So as you can see uh, here, as pitch angle increases, the thrust is also actually increasing. Yeah. For the blue one, the pitch angle is 0. You can see it's lying below here. And for the red one, 14.9 is the pitch angle, and you can see it's lying above. Yeah. Yes, propellers. So, guys, again, what do you know about propellers? You guys can keep commenting. Yes, rotating blade. I saw a comment from Piyush Raj. Yes, so propellers are the rotating blade only. Whenever you like, you can see the propellers image here. Whenever you go to purchase a propeller, you see this measurement actually, A into B, where A indicates the total length of blade from end to end. Basically, it's the diameter, and B is the pitch. So whenever you see something like 6 into 7 on the measurement, that means the diameter of the propeller is 6 inches, and the 7 is the pitch here. And here's the question, guys. Which one is more efficient, the larger or the smaller propeller? You guys can answer. Even if it's wrong, it's free. I'm here to explain. Yes, Vishwajit mentioned larger, right? Can you guys tell me why larger one is the most efficient one as compared to smaller one? Yeah, okay. Pitch to diameter ratio decreases. Yeah. Uh, Vishwajit, let me explain you about this. So yes, larger propeller are the most efficient one. You can see that you using this momentum theory intuition, where you see uh, thrust equals mass flow rate of air into increase in velocity of the air. So basically, for the same thrust, you actually have two options here. either you increase the mass flow rate of air and keep the increase in velocity constant, change in velocity constant. And another one option is you keep the mass flow rate of air constant and increase the change in velocity here. But the second one actually consumes a lot of energy because to change the velocity of the air, you need to borrow uh, voltage from the battery. But in the first option, where like larger propeller can achieve this, like it can increase mass flow rate of air as it has larger area and it can sweep larger amount of air. So yes, that's the reason why large propellers are more efficient. As you can see, the large propellers provide more lift because they can sweep more amount of air, so they provide more thrust, more lift basically. And yes, as I said, uh, for larger propellers, they won't like consume that much of power as compared to smaller one. So low current draw, more stable flight, and longer flight time. Even you can see a small, more responsive, higher top speed. Yeah, you can go through these slides. And here's another question for you guys. If more blades produce more thrust, then why don't all drones use 5 or 6 blades? I'm actually waiting for your response, guys. So yes, drag is actually considered here. Amog is right. Anyone else? Mass increases. Okay, so Sadil, let me explain you. Yeah, the area said more turbulence faced by the other plates. Yeah, true. That's also considered. Here, the thing is, uh, although like if you keep increasing the number of blades, thrust, it generates more thrust, but it comes at a cost actually. The drag, turbulence, and power consumption, as you can see here. And here's some comparison between two-bladed propellers and three-bladed propellers. Two-bladed propellers, less drag, higher top speed, long range focus, more drag, better control feature. So can you guys tell me why two-blade propellers have higher top speed as compared to three-blade propellers? It's very simple, guys. Because two blades face as area is less, they face less drag. So with the same motor and a battery, they face lesser drag, so they can achieve higher top speed as compared to the three blade one. And better control. Yes. Can anyone like try to explain why three bladed propellers have a better control? More stability, less speed. Yeah. Okay. So yes, Vishwajit said less speed. Advait said more stability. Amog said more thrust at lower speed, which control more sensitivity. Sensitive. Yes, then so let me explain you. Better control in the sense here you guys know the here as you can see the area of the blades has been increased and it interacts with air, so it accelerates it accelerates more air, so more thrust is generated. And whenever you try to maneuver your drone, whenever ESC tries to change the speed of the motor, uh, thrust change thrust changes are strong here, so that's the reason three bladed propellers are for better control. Now let's move for the electronics part. So can you guys just tell me what all electronics we use in the drone? Yes, Samok said ESC, right? Piyush Raj said battery, yes. Servo controllers, yes. We use BLDC motors here and flight controller sensors. Yeah. Right. Yes, you guys are right. So let's start with ESC. ESC is electronic speed controller. So ESC, as you ESC controls rotational speed of the BLDC motors. And one thing need to be noted here: ESC's amp rating must be like greater than the maximum motor current drop, because internally ESC has MOSFETs which can be damaged if this condition is not mentioned. And before purchasing a ESC, you need to check whether it supports your battery cell count, like as mentioned here, 3S, 4S, and 6S. Yeah, and yes, BEC, battery eliminator circuit. Why do you guys think it's necessary here? Battery eliminator circuits. Yes, Vishwajit said to not try the receiver, right? Yes. Uh, BEC is basically it's it is an electronic voltage regulator which converts the main battery voltage into lower, because these drone electronics are designed in such a way that they run on a lower voltage. So to control that and to for the safety of these drone electronics, we use this BEC, battery eliminator circuit. Yes. And as you can see here in this is ESC, and these these uh, these black and red wire. This thing is uh, for the battery section, and this black, red, white, these three connected wires together is for receiver, and these three blue wires are for connecting. These are connected to the BLDC motor, which you will see in the upcoming slides. Yes. So here's the workflow of the ESC. So you guys, like, if anyone wants to explain how a ESC works, you guys can explain it in the comments. Advait is asking what should be the amp rating of the ESC for a 3S battery. Advait, we will see that in ECalc tool, which I'll be covering later. So let's focus on workflow of ESC right now. Yes, so here's the workflow. Battery supplies DC power, flight controller sends the throttle signal, ESC receives signal and convert DC power into a three-phase pulse. ESC energizes motors coil sequentially, and rotating magnetic field generates and motor starts spinning. So let me tell you guys something. Here ESC is doing two things, two jobs simultaneously. One is this commutation and another one is pulse width modulation. So commutation basically it controls like uh, which which motor winding to be powered, and pulse width modulation basically it controls how much of current is actually delivered to these motor windings. So commutation is the process by which ESC switches the current between these motor windings, so that the magnetic field which is generated keeps rotating, and also, and because of that BLDC motors keep spinning. And you guys might think why this continuous commutation is required, because let's say if ESC energizes only one set of motor coil, the after some time the rotor aligns with that magnetic field and it stops spinning. So to keep it spinning, ESC energizes motor coil sequentially, and it repeats this sequence so that rotating magnetic field generates and it keeps continuously rotating, and then that's how the motor starts spinning. And for the pulse width modulation, let's say we have a 10-volt battery as a voltage supply. We can't just supply 10 volt continuously to the motor. Sometimes it might be 80%, 50%, and sometimes it's 100%. It all depends on the pulse width modulation. Pulse width modulation handles it, and you guys might encounter this term called duty cycle. Duty cycle is nothing but it explains you how much the current is being supplied to these motor windings. Yes, and as this pulse width modulation actually controls the torque and RPM, which I'll explain you later in the motor section. Yes, so let's keep moving. Yes, here's the power distribution board. Uh, you can explain. Anyone can yeah, keep ask. You can comment on something if you are feeling like any doubts or something. Power distribution board, guys. Okay, nobody is commenting. Let me explain it. It basically acts as a central power hub between all the electronics, and it simplifies the wiring and power management. Yes, this is must condition as it manages power as it deals with power management. The current rating must exceed expected total system current. Yeah, that's the must condition. And in modern FPV drones, PDB functionalities often integrated into these 4-in-1 ESC boards, flight controller stack. Yes, so battery. So what do you know about batteries? You can keep commenting, guys, so that I can like interact with you guys.
Subramanya, you're muted.
Yeah, yeah, sorry for that. Okay, then yes, supplies current. Right, let's move then. So battery selection directly affects flight time, thrust, agility, and efficiency. Here are some important battery parameters: uh, cell count, capacity, and C rating. So cell count, yes rating indicates the number of lithium polymer cells connected in series. Uh, as you can see here, nominal voltage of a lithium polymer battery is 3.7 volt. For example, if let's say you have a 6S battery, so you can calculate its voltage like 6 into 3.7 volt. And yeah, one thing to mention, if you guys encounter like these are S rating, here cells are connected in series, but when you connect these cells in parallel, what happens is voltage remains constant, and yeah, voltage remains constant, but the capacity actually multiplies. Yeah, so capacity is a milliampere hour. It basically tells you how much charge the battery can store and how long it can power a device. Yes, and C rating, just a sec. So here's the C rating. Here's the C rating. C rating indicates how fast a battery can safely deliver current. Determines maximum discharge capability of lithium polymer battery. To understand the C rating, here's a like very basic example. Using this, you can understand it. Let's say if a battery, you have a battery with the capacity of 1000 milliampere hour, and it is rated as one coulomb, then it means that it can provide 1 ampere for 1 hour. And if the battery with the capacity or with the same capacity is rated as 2C, that means it can provide 2 ampere for half an hour. Yes. So here's the maximum current formula. Maximum current equals capacity into C rating. Yes, so let's know it. Here's the lithium polymer battery versus lithium ion battery. Yeah, this is power versus energy. Lithium polymer battery, as you can see, it is for high discharge capability. It has higher C rating, delivers high current instantly, higher thrust performance. And yeah, similarly, you can like see for lithium ion battery as well. I've listed it down here. The key points to be mentioned here is current draw into expected flight time should be less than rating of the battery, and 4.2 volt is max charge voltage for LiPo and 3.2 voltage minimum. And as I said, 3.7 is a minimum nominal voltage for both lithium polymer and lithium ion battery. Yeah, so here's the deciding weight. You might have encountered this thrust weight ratio. So yes, thrust should be always greater than twice weight. Yeah, you here's a note for you. As you know, thrust to weight ratio increases, performance increases, but it also has difficulty controlling in drone, because you can see that if performance increases for like small inputs in throttle, the drone responds quickly, so it becomes very difficult to control the drone. Yeah, let's start with the motor. So KV rating. Basically, KV rating. KV indicates the number of revolution per minute. Motor turns when 1 volt is applied without any load attached to the motor. You have the formula for this KV rating. Voltage into KV rating equals RPM. More volume results in more torque, more inertia. Yes, here the inertia meaning, let's say more inertia means, the for smaller inputs, motor can, for larger inputs, motor responds like slowly. It accelerates and deaccelerates slowly in this more inertia case. And yes, the torque of the motor is estimated by the stator volume, and dimensions of this stator is represented by ABCD, where AB is diameter and CD equals height. Yes, this point to be noted, guys. And larger propellers are typically paired with low kV motors, and while smaller lighter propellers work better with high kV motors. Yeah, so I'll explain the reason behind this. So basically, when as you can see, here are these permanent magnets attached in this motor, and here are the copper windings. So when a BLDC motor starts spinning, as I explained in the ESC part, the so there is a continuous rotating magnetic field. Because of that, we get a change in flux. You guys might have studied in 12th standard Faraday's law. Because of this change in flux, we get a back EMF here. This back EMF, it opposes the voltage supplied, and after some point, the voltage supplied and this back EMF approximately becomes equal, and that's the peak state where the motor is at its highest speed. uh, yeah, after that point motor can't increase its speed. So for high kV rated motors, internally copper windings are less, so because of that, EMF generated is low, back EMF is low actually. Yeah, and similarly for low kV rated motors, internal copper windings are more. Because of that, the flux generated is more, and EMF generated back EMF is more here. So let me explain with an example. For a low back EMF generated and for a high back EMF generated. For low back EMF, let's say one volt back EMF is generated for a 2000 RPM. Meanwhile, for high back EMF, 1 volt is generated at a 1 volt is generated per 1000 RPM. If the voltage supply is 10 volt, as you can see here clearly, at 10 volt, the low back EMF generated will have 20,000 RPM, and where the one with the high EMF it has 10,000 RPM. So that's the reason why high kV motors have high RPM, and low kV motors have low RPM. And the reason why high kV rated motors are paired with light propellers, because internally, as I mentioned, high kV rated motors have least number of these copper windings. You might have studied this formula. When we keep a current carrying wire in a magnetic field, it exerts some force, and that force actually depends on the number of turns as well. As here, number of copper windings are less in high kV rated motors, the torque generated is low here as compared to the low kV rated motors. So that's the reason that why these are paired with lighter propellers, and low kV rated are paired with larger propellers. Yes. So here's some data which you can see. Prop diameter 31 mm for a propeller diameter of 31 mm. Here's the, yeah, 0.6 is the diameter basically, and 0.3 is the height of that motor. Yeah, you guys can take a look at these data afterwards. Yeah, here's also a data. Crop diameter, battery voltage, and recommended motor kV. According to the battery voltage given here, you guys can see the recommended motor kV rating as well here. So far, any doubts you guys are facing? You have any doubts? Post in the comment. It's fine then. Let me move towards ECalc tool. Whatever we have learned until now, we'll be testing it virtually. So just a second, let me open the ECalc tool for you guys. Park, can you just tell me my screen is visible?
Yeah, it is visible. Go ahead.
Yeah, thank you, thank you. So here, just a second. Yeah, this is ECalc to ECalc, and when you click on it, you select the ECalc for multi-rotor here. Yes, and uh, it's free for everyone. You guys can analyze it. You guys can try it on your own. For multi-rotor, it's free. So let's check. Let's keep our, here are some tabs. In the general tab, first we set a model weight and battery cell and controller. This is related to ESC. And here we have a motor section where we can adjust motor settings and propeller and diameter, pitch, and power constant, thrust constant, and after calculating it, it will give you a result. So let's check it. So actually, I have a data for this. So let me check it. Just a minute. Yeah, 1,100, and here including drive means including all the weights of the electronic part, and without battery, without drive. Yeah, without battery, if you select, it will exclude the battery, so battery power, battery weight, and also without drive, it will exclude the electronics weight. So let's go with without battery, and flat coaxial. I have mentioned this in slides, which you guys can take a look at it later. And FCO tilt. Yeah, so FCO tilt meaning the maximum angle at which the drone can, the flight controller allows the drone to tilt while, changing the direction. So you can set it here. Let's keep it. And here's the environment part: field elevation, air temperature, pressure. Field elevation basically above sea level. As you guys keep going above, at a certain height, air density becomes thinner, and the aerodynamic uh, thrust and motor efficiencies changes. So this needs to be also considered here. Yeah, and so the battery type here, you can see there are many more battery types. So yeah, so let's select this 4500 mAh battery. Yes, 80C and 120C. So continuous C rating, meaning the C rating through which the battery can keep discharging continuously safely. While this max C rating is whenever a motor requires any power burst, that time one it can reach up to 120 C. So here's 3S. This is the, as I mentioned, S rating. And yeah, this P is basically what happens. It's the parallel. If we connect these cells in parallel, if I make it 2, the capacity of this lithium polymer battery becomes double. Yeah, let's keep it 1. And max discharge capacity, you can also alter it here. Resistance, this is the internal resistance of the battery. And yeah, this is the nominal voltage. P rating, weight, yes. So yeah, controller. This is for ESC. Let's say I select 30 ampere or that maximum permissible. Yeah, as you can see, continuous maximum. Yes, it is also very similar to this continuous and this maximum. Here resistance means actually ESC has internal MOSFETs in it. So yeah, it has a very low resistance and weight of it, and accessories. Accessories meaning any additional electronics like video transmitter, GPS. Yeah, you can add that to weight here. And yeah, in the motor section, you can select manufacturer type. Let's select Airtech. And yeah, this is basically these 2836 are basically the dimensions of that motor, and 1120 is a kV rating. Yeah, it's it. As you can see, yeah, no load current and limit up to 15 seconds. Yeah, limit in the sense, yeah, motor can stand whenever motor requires like sudden power burst. It can maximum it can reach up to this power, and it can withstand for only up to 15 seconds. If you keep it more than 15 seconds, actually internally these copper windings inside the motor have a thin insulation coating, which might get burnt, and which short circuiting occurs. Yes. Resistance, it's same. It's the resistance of these copper windings. And yeah, case length, mag poles. Mag poles meaning, as you saw in the slides which I showed you earlier, there were so many magnets attached internally. So these are the number of magnets, and motors weight is here. And yes, type yoke twist meaning it's a aerodynamic structure of a propeller. Let's keep it generic thing. And yeah, this is the pitch angle which I mentioned earlier. As you can see here, you can set a diameter, pitch, blades also, two blade, and power constant, thrust constant. Power constants meaning it basically tells us the resistance faced by the propeller. Yeah, aerodynamic drag. And thrust constant tells us how efficiently a propeller is generating thrust. Yeah, here in this case, one is actually a very efficient one. Gear ratio. Yeah. So let's calculate for this. Let's see what all data it gives us. Yeah. Yeah. Here you can see it gave the load 18 point battery section, motor section, and motor maximum current, motor hour, total multi-factor. Yeah. So if I like just let's say if I make it 15, as you can see it, here you can see it. These these propellers are physically interfering with each other. So yes, let's keep it 10 only. You can like measure it. Yeah, this is safe. Here's some propeller clearance gap. And let's see. Yeah, here are some remarks. Let's see. Max current is over peak limit of the speed controller. See, it already alerted you about this. Select a stronger ESC to avoid damage. Yeah. Mm, yes, you can see the remarks, and according to that, you can choose your uh, proper components. And yeah, here are some graphical analysis, range estimator. So this one stand, this lighter one stands for flight time with no drag. As you can say, 9 minutes, it keeps decreasing and it reached like 0.75 miles. And range, dark orange is range with no drag. This one, this is the range without any drag. And dark blue one is range including standard drag. As you can see, when we include the standard drag, range is decreased. Similarly, flight time has also been decreased. You can see here. Yes, and yes, EL power basically means electrical power input. This is for, yes, as you keep flying your drone, power consumption increases. Yeah, you can see here. Efficiency, you can see here. Max revolutions and waste power. Waste power means power loss. Yeah, you can see that to here. Motor case temperature. Yes, it tells the temperature about motor cases, and yeah, that's it. This was all about ECalc tool. I hope you guys understood it well. Uh, are there any doubts? Guys, you can post your doubts in the comment section. Is the pitch of the rotor constant or changeable? Pitch of a rotor. Actually, pitch is for dhairya, pitch is for propeller. So according to the that you can like change, you can purchase the propellers by seeing the pitch, but you can't like change the pitch. LDC motor. Should I?
I think all your queries are answered by, and thank you,
Yeah,
Subramaniam, for taking this topics. If any of you has any further queries regarding drone sizing and ECalc, you can type on the chat, or at last we will also have a Q&A session for few time. So, good evening, everyone, and hope you all are enjoying your summer vacation. So let me introduce myself. I'm Divyansh Singh, and I'm to be Sophie from the Aerospace Department, and I'm also a convener of the Aeromodelling Club. And let me share my screen. And today I will be taking you through the topic of INAV. So let's begin. Is my screen visible?
Yes.
Uh, okay. So let's begin. So basically, INAV is a software. INAV is a firmware that you can use to enhance your performance over a drone or a fixed wing airplane that you will be building for the ITSP programs. So before we go dive deeper into the various features and functions of this INAV, let us first take a look over few topics such as understanding flight controllers and firmware. So let's begin. So basically, if you want to make any drone or any aircraft, to make it airborne, you connect it, like you make different control surfaces and then connect these control surfaces to various servos and ESCs. Now, to control the ESCs or servos, you usually use a joystick or like a transmitter that you alter the joystick settings and control how you can fly the drone or your fixed wing aircraft. Now, we need a hardware, like a piece of hardware that is present between transmitter and the controls, servos or ESCs that guide how your control surfaces work or how your drone or aircraft flies. So that piece of hardware that controls or communicates things between the transmitter and the servos or the ESCs is the flight controller. And basically, flight controller have three different tasks that are performed by flight controller, which are mentioned here. The first is perception, which is in simple terms sensing. Like flight controllers have numerous sensors on board that like help it to like generally see what height your aircraft is flying or what speed your drone is on. For example, we have IMU, inertial measurement unit, to measure the angular speed and acceleration of your drone. Then we also have in flight controllers barometer, from which you can measure the pressure of the air at which you are flying, and through the pressure you can also estimate height at which you are flying. And also we have the Pitot tube, which is used for measuring speed. So this perception is necessary as like you need all the data that a pilot needs to drive or control a drone. The next function is controlling, which is through a transmitter. Basically, you have a transmitter that have two joysticks in it, and you basically alter the thrust and change the direction. You can change directions, and in case of fixed wing aircraft, you can roll, pitch, or have yaw moment on it. Then the third function that a flight controller performs is communicating, which is a crucial part as the pilot needs to be aware of what height the drone is flying or what is the power of your battery, how much battery is remaining, so he can plan accordingly a return journey or like decide things accordingly. And see this, you can see this is a picture of a flight controller. Here various UART ports are available, which you can connect various peripheral device such as a GPS module, or if you want to connect it to a SPV, you can connect this also. And here few of the popular flight controllers are mentioned. Now let us move forward to the next thing, which is firmware. So the topic here, INAV, which we'll be covering in detail in the later slides, is basically a firmware. Now, what does a firmware do? So, to enable a flight controller to perform a various function, to add certain features to your flight controller to guide how your drone or how your fixed wing aircraft will act when it is in air, we use the firmware. We use a firmware. It is a software which is to be uploaded into your flight controller, and then you can manage this software using a PC application that comes with mostly all the firmware available. And this PC application can be used to update and install, update and like upload the latest version of this firmware into your flight controller. Some of the popular firmwares that we have in market presently are Betaflight, INAV, and ArduPilot. And we will be focusing on INAV in this session. So let's move forward and see what are the features and why we should use INAV. So as we have seen that there are various options in the market available for different firmwares that we can use, such as Betaflight, ArduPilot, and INAV. So, like, why do we prefer INAV, or which situation do we prefer? We will see in the next slide. So, this slide offers a comparative view on different flight firmwares that are available. So, first of all, there is like nothing like a it's nothing like a hierarchy that this firmware is better than this or this is better than that. But different firmwares are used for performing different functions. When you have to perform, like when you are going for a competition that is based on freestyle racing, most experts prefer to use a beta flight as a flight controller. And if you are planning on conducting some complex missions, such as you are mapping an agricultural field, or you are using your drone for conducting some industrial missions, such as pick and place and other things that are useful or helpful in the industry, you generally use the ArduPilot's firmware. So now let's come to our firmware in focus, that is INAV. So where do we use INAV particularly? So let me explain. So INAV was basically built for navigation. It is excellent and one of the most successful and most utilizable firmware in terms of navigation. So whether if you have to like use your GPS a lot in your missions or your ITSP projects, you have to use a lot of navigation related stuff. The firmware that I will suggest you is INAV, and it's basically like it can be used for quad drones, or fixed wing aircrafts can also use the software. Also, our INAV has certain important features such as return to home or on-screen display and auto launch feature, like which provide it an edge over other two of these firmwares. So now I hope it's clear that we will be using the INAV for basically two purposes. First, if we have to use navigation intensive missions, and next, like we prefer it to use with the fixed wing systems. Now let's move forward. So I will also like to remind you all, like if you all are facing any doubts, you can always put it in the comments, or we will also, after we complete the slides, we'll also have a session for Q&A, so there you can ask too, so you can note your doubts too. I think we should proceed further. Now we will proceed to the part of installation. This is a brief installation guide about how you can install this software or firmware into your laptops or PCs. So let's see what it is. So you have to search GitHub INAV into your browser and then open the github.com link, which is there to download INAV Lite. Then you will scroll down and you will see the window of INAV configurator, and you can proceed further with that. Moving on to our next step, we this will be the window which you will get after you will click on the here section in the INAV configurator window, which was there on the last slide. And when you scroll down it a bit, you will have the option to install the latest INAV version. Presently, the latest version in site is the INAV configurator 9.0.2. So like you can look into the like they like they update the software frequently, so you can look for the recent versions and download it accordingly. Then you can select which file to download, which zip file to download according to your OS system, operating system. So I think the installation is pretty clear, and like it's very intuitive, and you all can also proceed with that. After installing, it will also ask you a few questions, and like as few setups have to be done in laptop. There might be a chances that it will be asking your computer will be asking that whether to allow this software or not. It is an unknown software. So you can proceed with that. It's all safe. Now, I think we should move forward with the topic. Okay. So now let's see what flashing is, what flashing a flight controller is. So basically, flight controller is a hardware part, and the firmware which you have downloaded, like the INAV for example here, is a firmware. So now you have to upload your firmware, which is a software, into your flight controller, which is a hardware. So to do this part, like to upload your firmware into your flight controller, this process is termed as flashing. For this, you have to do nothing but just connect your flight controller to your laptop or PC with the help of USB port, USB cable, and then you can you can select the option. As you can see here, the firmware flasher option is there, and there you can select the target. Like here, for in select target option, you can select the name of your flight controller which you have added. Flight controller, basically here we have used the Matic one, and various flight controllers are available like iSpeed and etc. So you can select that accordingly to your model. Moving forward, we will now be exploring how we will now be exploring INAV firmware and see what are the various features and what it has to offer in terms of each its sidebar. So let's begin. Huh, Look. So after you connect your flight controller with your PC or laptop, you will see an extended sidebar menu, which will include a lot of options here. So this menu will be only be visible after you connect your flight controller to your PC. Then the first tab in the sidebar which you will see is status. So let's look what status tells us about. So basically, before having this view, when you go to the status tab, the INAV will ask you a few questions about which type of aircraft or which type of system are you using your flight controller for. Like, are you using for it for a fixed wing or are you using it for drones? So the option which you will select will be accordingly that model will be accordingly shown in the middle, and here there will be a checklist of all the calibration, whether the calibration is completed or not, or whether your whether your firmware is loaded, whether like it's pre-armed or whether it's safe to proceed. So you can look into the various options available here and see like what all things you have to do and what all things are remaining. So now let's move forward to some valuable options on the sidebar. The next thing that you will have to do after after flashing your firmware to your flight controller is calibration. So let's first understand what do we mean by calibration. So calibration is a process it's a method which it's a process in which you uh, basically set various sensors that are present in the flight controller to its initial or to its mean values. For example, there is a sensor in the flight controller that measures the angle with respect to the ground. So like it tells you whether your aircraft is moving tilted or whether your aircraft is moving stable. So here in calibration, you will place your flight controller in stable horizontal position. So that will be taken as mean position. And if you do not calibrate your flight controller, then some other position can be taken as your mean position. And even if you are flying a little tilted, your aircraft a little tilted, then also the IMU, the sensor will not judge or sense it, and you have to do it with the joystick. So that will be a trouble. So first we calibrate our flight controller. In INAV, to calibrate a flight controller, we follow a 6-point calibration method. As you can see, there are 6 steps mentioned here. These are the 6 position in which you have to keep your flight controller. And after going through each position, you have to click on calibrate accelerometer option. So like you will place your flight controller and at the first position, and then click on calibrate accelerometer, then place your flight controller in second position, and then again click on calibrate accelerometer, and you have to follow it till 6 times. So once your calibration is done, we can move forward to different to other options. Now, this is the mixer tab in your. This is the mixer tab which is available on the sidebar. So let's look what it does. So basically, to control your drone or to control your fixed wing aircraft, you will have a transmitter. You will use a transmitter which will look something like this. So the transmitter has two joysticks. Mostly all the transmitter has two joysticks, and there are channels in the transmitter. For what do I mean by that is that, for example, the left joysticks, you can move it up and down, and you can move it left and right, sideways too. Similarly, you can do it with the right joysticks. So up and down is one channel, left and right is another channel. So these are channels. It determines how your various servos or how various ESCs move accordingly. So here in the mixer tab, you get an option to select various servo or ESC in one channel. So here in this, in the INAV setup, they are defined as timers. So in timers, for example, you have two servos for ailerons. You want to guide them, like you want to control both of them using one control only, using one channel only. You wish, like, if you move the right joystick left and right, then both of this should work accordingly. So what you do is that you place the servo 1 and servo 2, both the servos in a single timer, and that timer will be defined in a channel, and then you can use your transmitter to perform various operations on it. You can choose the functions accordingly as you wish. I think the mixer option is pretty much clear to you all. If you are facing any doubts or you have any queries, you can type it in the comment section, or you can also ask it in the last, or so you can just note it down. So moving forward, we have the ports tab here. So let's see what a port tab does in this section in the INAV. So basically, your flight controller has various UART ports which will be used to connect various peripheries to the flight controller, such as you can connect a GPS module, you can connect FPV system module to your flight controller. So you can get a variety of features in that. So after you connect any module into your flight controller, you have to come back to this port section and then go to the UART, like which UART you have connected your module, and then select the options accordingly. This will be more talked about when we look into the GPS and FPV setup. Now we begin with our next topic, the next menu in our sidebar. So, as you can see, there are a lot of menu in the sidebar, but as we have time constraints, we will be discussing only some of the important menus. So one of them is the modes tab. So what is in modes tab, you can select modes tab is used to assign flight modes to your aircraft or to your drone. Like here, you can select which flight mode your aircraft should fly, or which like uh, how much variation do you want your output to have when you change your channels with the transmitter you have. As you can see the slider here, this slider tells us that how much the min and maximum values, in the channel, when you, for example, in the right hand joystick, you are doing it up and down. So what is the minimum and maximum value that should be attained when you are at the bottommost position, and when you are the uppermost position. So this can be controlled by the slider here. We will be discussing this tabs in this mode tab in the next two slides also. So as you will be seeing in the previous slide, you have this arming column. So let's see what does arming mean, and how can it be helpful to us. So arming is a process of preparing the aircraft, which enables the flight controller to send power to your motors. So if you want to fly an aircraft, you will need a motor which is connected to a propeller. So to send power to the motor which is connected to the propeller, you have to uh, first arm it. Arming is the process of sending power to your motor, and to prevent any accidents on like unintentional unintentional use of transmitter, by mistake you deferred some joysticks in the transmitters. So to prevent any accident, we have a pre-arm checklist. We have to check the pre-arm section, and it has a message that nothing is in the surroundings of the propeller, so everything is safe when we move up the throttle. So that is arming, and the throttle controls can be seen, you can change them. The minimum and maximum throttle can be set here accordingly, using the slider, as we discussed the maximum and min value. So let's move forward. Now we will be discussing one of the most important features of INAV, or how you can use different flight modes to achieve your different mission profiles, and how these different flight modes work. So basically, INAV, or in that case, any firmware that you have offer these 5 basic flight modes that can be used to guide your plane or drone in when it's airborne. So let's look at them one by one. First, we will look at this manual mode. When you turn on the manual mode, when you select the manual mode, the flight controllers offer the firmware, which is INAV in this case, offers no stabilization. Your transmitter is directly connected to the receiver, and whatever you do in the joystick will be the same will be reflected in your servos, which are connected to your control surfaces. So it's all if everything if the pilot wants to control everything, every single servo, he wants to control every motion, then you can use the manual system. Here, the firmware, which is INAV, has no role. No stabilization is provided by it. The next mode which we will be discussing is the acro mode. Acro mode. So acro mode is the default mode. If you do not change any of the modes in your firmware, the default mode which it will be set to is the acro mode. Here, it's basically same as the manual mode. The pilot controls everything, but it offers a little stabilization in terms of altitude. Assume you are there in a certain altitude, and then the pilot is not controlling the pitch. If the pilot suddenly stops controlling the pitch, the aircraft tends to move down, tends to become hit the ground and descend in terms of altitude. So when the acro mode is turned on, then there is a stabilization in terms of altitude. So your system, your aircraft will not descend at a fast rate, or will not hit the ground. Next mode that we will be talking about is the angle hold. So in the angle hold mode, you basically allow this firmware, the flight controller, to maintain your flight or to maintain the flight of your fixed wing aircraft or a drone at a certain angle. So it will move forward, and at all the times of its movement, it will be tilted at a certain angle with respect to the normal neutral level. Next in the discussion, we have the angle mode. So what we have in the angle mode is that if the pilot suppose the pilot in suddenly in the middle of the flight moves the joysticks to the extreme ends, like he wants to roll or flip it completely, then the angle mode will not allow. Angle mode will allow roll and flip in up to certain level, but it will not allow your aircraft to roll a lot, like roll wholly. So it offers it's very useful for new pilots to use this mode, as it allows the plane to be around a certain mean level. Then we have the horizon mode, which is very much similar to the angle mode, but the only difference here is that here the pilot can, if he wants, he can roll and flip the aircraft or the drone. As if you have your joysticks controlled towards the center of towards the mean values, it acts like angle mode. But if you move your joystick to the extreme ends, your aircraft can roll and flip. So that a pilot can see. I hope you all are clear with the flight modes. Again, I'm saying if there are any queries with regarding to any of the flight modes or any of the topics, you can post it in comments. So I think we should move forward. In this part of the slides, we will be going through and uh, see how to set up GPS into our drone or into our fixed wing aircraft, which we'll be building for ITSP. So let's begin. So this here, as you can see, is a GPS module. It's a small module which needs to be connected to one of the UART port of your flight controller if you want to have your aircraft or drone to have navigation properties, or if you want to trace where it goes. And there are certain advantages of connecting a GPS module to your drone or your aircraft. Some of the advantages are you can use the return to home feature. If there are anything mishappening that is happening to your drone or to your aircraft at a far away distance, or the battery dies suddenly, then your aircraft or drone will return to home suddenly in that case. So that is one of the feature that has been enabled by using a GPS module. Likewise, there are many other features which can be enabled. You can also build a boundary using the firmware geo boundary, your drone or your flight will move in this particular geological region only, like a particular location only. It will not move beyond it. So now let's look how to connect this and all. So once you connect your GPS module to your flight controller, then you have to come back to the ports tab, as was earlier mentioned by me. You have to come back to the ports tab, and while you're connecting it to your flight controller, just check which UART port are you using. And in that UART port, in the sensors drop-down menu, you have to enable the GPS mode. Once you do this, and if the firmware INAV detects that a GPS module is connected to it, then there will be an additional option that will be shown in the sidebar, which is of GPS. And you can go in this tab, and you can find the exact current location where your GPS module or where your drone is. Also, I suggest you all to turn these on, these all the satellites on. These are the options that ask you whether you want to connect it to this satellite or that satellite. So connect this all for better navigation and all. So now we have seen how we can connect the GPS tab in this in your drone or your aircraft and use it for navigation purposes, as many of your ITSP teams will be using them. Now let's move forward and look how we can connect a camera to your drone or to your fixed wing aircraft. We will be setting up the first person view camera here. So let's look into the FPV setup. So here. So basically, a FPV camera or a FPV setup has four basic components. Just a minute. Let's come back to the slide we were on. So basically, a FPV has four basic components: the FPV camera, the FPV goggles, video transmitter, and antennas. Let's see how we can connect them all and obtain a view from the ground station. So first thing is the FPV camera that is to be connected to your aircraft or drone, which captures the video signal and captures all the information, video information that are present there. Then the FPV camera is connected to the video transmitter. Now the role of the video transmitter is that it converts the video signal into radio signals, and through the use of these antennas, it transmits the radio signal back to your ground station or back to your firmware. Say like in the firmware, you can view the video. So the video transmitter converts it into radio signals, and then using antenna, you can it transmits it, and you can see it in your ground station. See the video in your ground station, which your drone is capturing. Now let's look how we can power up our setup, our FPV setup. So here you have to like to power up your FPV setup, you generally need a 6 or 9 volt power supply. And it is advisable to not connect it directly to any power supply, connect it directly to any battery. It is very much advisable to connect it to the 9 volt UART port in your flight controller. One of the advantages of it is that you can like it's a very reliable source of fixed voltage to your flight controller. Also, to like the flight controllers, the FPV's video transmitter communicates the data to your flight controller or to the ground station in this MSP protocol is used here. Now let's move forward and see how we can set up this FPV into the INAV setup. Now, once you have connected your flight controller into your FPV into your flight controller, you have to come back to your firmware, the INAV window. And again, as I have mentioned, you have to go to the port section. And there you will see the MSP display port. Like in the peripherals option, you have to click on the drop down menu and select the MSP display port option. So this will allow your INAV firmware to get access to the video that your video transmitter is sending it and display it to you. Now, if your FPV is detected by your firmware that is INAV in this case, you will get an additional option in the sidebar that is OSD on-screen display, and there you can go and look into the video that is being recorded by your FPV camera, and you can also select what all specification will be visible to you once you wear your FPV goggle. Or if you don't wear your FPV goggle, then also what all information will be visible to you, height or the battery and all. So I think this was my part for covering the INAV in detail. If you have any queries, any doubts, you can post it in the comment section, or you can even reach out to us later. As we are approaching to the end of this part one of this ITSP bootcamp. We will like to summarize what all things we have done in this section. So first, Subramania explained to us drone sizing and ECalc, where he talked about how you can choose the various frame size or that uh, what is the efficiency of larger props and how the efficiency decreases when you use smaller props. He also talked about the ESC amp rating and how you can how different things work when you have different amp rating. Also, he talked about S rating of battery, the kV rating of motors. He also talked about the very important thrust rule, in which he mentioned that for any drone, the total thrust should be greater than twice the weight to work efficiently. In the last, he also explained you like how basically you can choose your motor for a particular mission or like for a particular purpose, how to choose your motor choice, like prop size and like how you can how to differentiate between prop size, RPM, what to choose according to different purposes. In next session, like in the next part of this workshop, I talked about the INAV part, in which first we covered about the differences between flight controller and firmware, and then we talked about two additional firmwares to like Betaflight and ArduPilot, and what are their specifications and what are they basically used for. Then there are few slides that were included in their presentation that talks about the installation, like the installation guide about this. Then we talked about different menus that are available in your sidebar, such as status, modes, calibration, and etc. Also, in the slide, we covered the various flight modes, which were acro, angle hold, horizon, or manual mode. And the most important part, according to me, is that uh, we studied or we went through the part where we were able to do the GSP, GPS, and FPV setup. So, if you all have any doubts regarding these topics, you can put that in the comments. You can even reach out to us later. This was just the part one of our Dronexus ITSP bootcamp. We will also have a second part of it, which will be there on Wednesday, 3rd of June. So, like, if you guys don't have any doubts, like, peek into the topics that we will be covering into the part two of our workshop. So, we will be talking in the upcoming part of the bootcamp. We'll be talking about basically three topics: Pixhawk, ArduPilot, and IMA physics and sensor fusion. This will be taken up by three different speakers, and uh, we request you all to join this workshop too, as like it will be highly informative. And it will be of high use if you want to high use in terms of ISP teams, ITSP teams. So part two of this workshop is on 3rd of June. So please, we request you all to motivate your friends and you also to join this part of the workshop. So we are approaching the uh, end of uh, end of today's session. thank you for you all to for being connected throughout the session. And if you have any doubts regarding any of the topics, you can reach out any of the conveners of the Aeromodelling Club. In the poster of this Dronexus workshop, also we have two contacts number. You can feel free to message them or call them anytime. Like if you face any problems regarding any of the topics which we'll be covering in this boot camp. Also, we guys will be sharing the slides after the session on 3rd June. So you can once again go through the slides, and you can also share the slides to whoever you have not attended the workshop and want to learn more about the things. I think if you all do not have any further doubts for the moment, we can end this session. Thank you all for being connected throughout and listening patiently to us. And once again, I'm repeating, feel free to ask any doubts which you have, or any of the doubts which you have, any of the topics which you have seen in the slides and you have not understood. And also try to set up INAV if you are willing to use it, and see how things are working on your PC. And if